All right, college algebra. This will be my final lecture for the course. Okay. So just a quick blast. Everything needs to be done by Friday. Turn in everything by Friday so I can get you your grades. Okay. So this is the last piece. We need to graph these rational functions, and for us, we need to sketch them right by hand. So I have a couple tricks. So here's three rational functions that are completely simplified. So step one, like I talked about in the last lecture, is it's got to be 100% simplified or we don't even start it, okay? So sometimes with these rational functions, and you'll see this in your homework, it's better to ask what x doesn't get to be, okay? Because remember, x is the domain and we're going to get some kind of controlling function there, right? So if I look over here at this first one, this is called a BOBO. And this is called bigger on bottom equals 0, okay? And we'll talk about that in a second. But what we're looking at here is the power of the function. So see how this is just a constant function and this is linear? So this is much more powerful down here. So it's bigger on the bottom. But first, let's ask that question. What does x not get to be? Okay, so if we take this guy, and let's say we threw in 3 for x, well, we would get this relationship, right? And that's totally not doable. So how do I take $1 and share it with 0 people? How much does each person get? Well, there is nobody there. So that's an undefined problem, right? So this kind of situation means undefined. So what we're looking for is what makes the function undefined, right? So this x minus 3, it's just whatever makes that 0, right? So then what we do is we say, okay, well, when we go to sketch this graph, we say, hey, it doesn't get to equal 3. What doesn't get to equal 3? The x doesn't get to equal 3. So we know that that means it's a asymptote right there. X equals 3 right there, okay? Then we need to know the y asymptote. So rational functions always have 2 asymptotes. That's what's hard about them, okay? And that's what this trick's all about, this BOBO. So this is bigger on bottom, and so this is going to equal 0. So what we're saying here is the asymptote, this y asymptote, happens at 0. Another way to think of this is by letting these numbers go to infinity, just like in behavior, right? So let x go to infinity. Let it get super, super big, like a million, trillion, millions of dollars. So what I think of this is like Trump money. So this guy's got so much money. Does this $1 really matter? When you're comparing Trump money on the bottom, 1 divided by Trump money is so close to 0, we might as well call it 0, right? So then this is our basic function. And then we just ask ourselves, well, where is the curve? Does the curve go up here or down here? So if the curve's here, then when I put in this number like 3.1 for x, if I put that in here, see how it would have to be a positive output or a negative output? So if I put in 3.1 minus 3, I get a positive number. So a positive divided by a positive means that this curve goes up here, okay? If I put in the 2.9, I see that I get a negative number, which means the curve goes here, okay? So let's look at this one. So again, what does x not get to be? So that's where we start. We say, for this Betsy, we say, well, x doesn't get to be negative 2. So we put our asymptote at negative 2. And then this Betsy, see how this is a linear on top and a linear on the bottom? So this is bottom equals the top. And if that happens, we use the coefficients. So this coefficient's 3 and this one's 1. So we have an asymptote here at 3 over 1, or just 3, okay? So see how it has that second one? So this is a Betsy. Both the functions are the same, so we use the coefficients that's in front of the lead term, okay? Again, we're going to play that game, so we're going to put in a number right before that. So how about negative 1.9? If I put that in the bottom, I get a negative, right? So all I'm doing is checking the bottom, and I get a positive, sorry. But then a negative times a positive gives me a negative. So negative divided by a positive is a negative. So right next to this asymptote, we get a negative value, which can only happen down here. So that's our curve. Then we're going to check the other side. So negative 2.1, that would make a negative denominator, a negative numerator, and that's positive. So this is